Well, hi, and welcome to my shop. Thank you for coming and joining me today for another shot at advancing this radio. It's all about alignment at this point. But as I was just getting myself all psyched up to do that, just before I clicked go on the video here, I realized, no, this radio stopped working right at the end of the session yesterday for reasons completely unknown. That's where we're starting. We're starting with it not working. Now there's a good chance I'm going to turn it on and it's going to work. And it's going to work for a while until it quits again. That's one possibility. Or I'm going to turn it on, it's going to work, and whatever happened is just gone to history forever. Or I'm going to turn it on and it's not going to work, and I'm going to get busy trying to figure out why. But first, it's been many, many days since the sun has shone here. Have a look at this. Not much happening back there, but look at the sunshine, and my cats are out there somewhere. Okay, back to the task at hand. I think the first thing we'll do is we'll just start it up and see what happens. I have the signal generator running middle of the broadcast band, and the radio is on the broadcast band right now. Okay, and I've got this blasting here too. Let's just put that to so that's a strong antenna signal still. Okay, radio, what are you gonna do for me today? I have to turn it on. There we go. Volume up. What are we gonna get? Going to get a dead radio. So whatever happened has persisted. Kind of suggests it's a one-time thing. Whatever happened, it doesn't come back. Now, how can I be absolutely sure? I can switch to a different band. That's not a band switch. Well, isn't that interesting? So this would be one of the shortwave bands. The radio's working. The problem is one band. That sounds quiet. This is getting stranger. That's full blast. Huh? What's happened? Ooh, ooh. Is that the problem, or is that a new problem? What was that? Okay, it's just there's really no antenna connected here. This doesn't really count. Let's take this off. Oh, that's interesting. That had an effect. That's interesting. So this is the connection for the broadcast antenna, and this is for everything else, all the shortwave bands. And the two of them have to meet up somehow in the radio. So if it's connected, we have something tied, well, tied around here. I think the answer is no, it really doesn't matter. Now let's go up further. It goes, oh, does this ring a bell to me now? This actually bypasses some of this stuff. Is that right? Am I thinking right? So this is in broadcast mode right now. So no, the switch is where it would be Nothing is connected through the switch. So the antenna signal coming out of here is going right past all this stuff. I think I remember this now. Coming down, reaching these two. These are the tuning capacitor. This is the tuning capacitor C11, not C10, C11. And then it's in broadcast mode, so we're feeding the schematics in broadcast position. So we're feeding through here, getting on here, coming down through this capacitor, and there it is, reaching the grid. And it didn't even do anything here except these guys. It skipped all this stuff. Skipped this. It skipped this. Yet all bands are working equally poor. Kind of says this can't be the problem. The tube that just went south. What about that? How about the local oscillator going weak? That would give this effect if the local oscillator went really weak. Trying to determine the strength of local oscillator is a little tricky because every time you hook up equipment to try to measure it, you knock it out, knock it down. You really don't know what it is what the test result would be. So what's the easiest way of doing this? Look for it on the SDR again. See if it's still there. It's not a very good comparative thing, but I think that might help a little bit. So we could have a weak local oscillator for some reason. Could be the tube just coincidentally went south while I'm working here. And after that it could be all kinds of stuff. Maybe we better check that tube V2 and sort of get that out of the way. Like, this is really a lot of elimination here to get down to the problem. V2. 6K8 I think is what it is. V2 6K8. Yeah, I think we got to do that next. Okay, that's the decision. Okay, let's do the 6K8 here. I think I have this set up. Let's double check. 6K8, 6.32 signal level, 20L, 27345, 27345, 0610, 43, whoops, 6K8, 43. I had that wrong. C. Grid cap, heptode. Heptode. I think there'd be two tests for this too. There's only one. Yeah. Oh, Peanut, how are you? You just came in. Been outside all morning. No shorts. GM test. This one should come up to 780. 780 is actually about there. This is a two-part tube, but there's only one test here. I don't like that. I think I need to bring out another tube tester. One that'll do two tests on this tube. Yeah, that's right, Peanut. Okay, I think we're ready to go. I've already discovered a problem here because I thought I was shooting video and I wasn't. But I have the tube installed, I have the grid cap connected, everything's checked. This has been checked, double checked in fact. It's all correct. So we're ready now to do the short circuit test. In this tester, it's this light here that would come on. Okay. Oh my gosh. Okay, so I've never seen a tube that's just shorted on all these settings like this. I've also never seen a tube where you get one half of this lit. I had no idea it could even do that. So now I'm left wondering, okay, is it the tube tester? I've double checked this. I'm not going to double check it again. See, this is on English. No, this is on 3000. It wouldn't matter anyway. Nothing would matter except these. I have to get another 6K8 and stick it in there. But I think this is the problem. How come it passed that other tester? How could it possibly test okay in that other tester? I gotta bring out a third tester here. Let's test this tube in another tube tester before I go fishing out more tubes. I'll find another tube tester. Okay, let's give it a go with this one. Now this is a emissions tester. This isn't actually as skillful a test machine as the other two, but this is a highly regarded machine. Jackson. Isn't there a number on here? Jackson 648A. So you're going to see me set the whole thing up here. Here's the 6K8. It's 2 tests for it. First test, buttons are A, 1, 2, 3, 6. A, 1, 2, 3, 6. The second set is 4, 5, 9. 4, 5, 9. You set the big knob to 30. Big knob setting. The test setting is W and Y. When we push those, we're testing the tube. Grid cap. Just need the tube. The tube. Tube in. Grid cap on. Now you see it's just giving a good and a bad. And it gives a percentage from 0 to 130%. So you can guess 100% should represent a tube that's working nominally on here. We could guess. That's how they did it. 100 is right in the middle of the good. Okay, short test. Here we go. Short test. This light's this light, I believe. Here we go. What's going on? What's happening? Didn't show a short at all. You know what they didn't do with that other tube tester was pull the tube out and repeat the short test with no tube in place. That might show something. Okay, so we're ready to test this guy. It would be, wasn't it W and Y? W, Y. Wow, it's not exactly jumping forward. It's right on the line, so to speak. So, yeah, good, bad. Wow. Looks like it's suffering from old age. Let's just fool around with these settings and see how sensitive they are. That's fairly sensitive there. I mean, I don't have this right on 30. Okay. And I don't think there's anything else that can be adjusted here, really. Well, that's one half. Let's test the other half. Maybe the shorts will show up in the other test. So we pop the buttons out with these two. Releasers. Now we put in 1, 2, 3. 3. That's probably the start of the heater. AC 6.8. AC 6.8. Give it a little bit of time. So my tester that showed the short, that has been my go-to tube tester for years and years and years, and it's never really let me down. Never had a false test like that, anyway. Okay, shorts. The flashing light doesn't mean anything, it's just charges moving. Doesn't mean anything. And the test would be XZ. Wow, it's way up there. We can guess this is the triode. The first test was the pentode. Well, okay, so we got a what? I don't know what we got here. with the thing. You got to bring the other tube tester back and see what's going on. Wow. It doesn't, who's fixing a radio today? Apparently not me. Okay, one more shot at it here. I have more tube testers yet, so we can keep taking shots at it. I have to mention the man with 2 watches never knows what time it is. Something similar is going on here. JR 53476. JR 53476. No doubt those are correct. 11 and 50. 11 and 50. That's really all there is to setting this up. Press P4. Put the cap on. Okay, so we're going to run the test without the tube in there. Let's see what happens. No tube in there. Oh my gosh, look at that. What has happened? The tube tester has bit the dirt here. Is that because of this particular tube arrangement? Let's change a few switches. Let's do this. Put this onto a short. Goodness knows I don't know if this is a good thing to do. Well, the short is inside here, I think. Well, that's really too bad. Looks like I have another project. Now, what about the tube? So, the tube tested weak on the pentode, strong on the triode. Strong on the triode would suggest strong local oscillator operating. It passed 2 tube tests. It failed in the tube tester that itself failed. So I think the tube's okay in the sense that it can't be responsible for a deadening of the radio. It can't be the bad guy in this deal. Okay, I think I have a plan here. The radio's not operating, and without it operating, I can trace the antenna signal a distance into the radio. In fact, in this radio, I can trace it when it's on broadcast all the way to the grid of the mixer tube, because it bypasses, when it's on broadcast band, it bypasses a whole bunch of stuff. So that's interesting in itself, the fact that it works the same on, it doesn't work the same on shortwave and broadcast, so it seems. So what I want to do is, let's see, I have the signal generator running around 940. This is on RF, it's on band B, and around 940, 800. Oh, is that it? Oh. Let's find out. Okay, tune this guy a little bit. Yeah, it was it. Bad connection. My the cable here is short. So that's what it sounds like at the antenna. For sure we're on the broadcast band. Yes. And we should hear pretty much the same thing, I think. If I can get my machine up here, right here. We do. So the antenna signal is making it all the way to this tube. From there we can't do much more now without the radio operating. Go through the first tube at the same frequency it is. Oh, it doesn't go through the first tube, right? It goes around, right? Goes around, so, but it doesn't work on broadcast. So we've kind of eliminated the problem. I cannot, from being in the front end. So we want to look at the output. We want to look at the oscillator. I should check the oscillator. Let's do that next. So I'm going to stop the video for a second, get everything going for that. Okay, so I'm gonna start out with the pickup coil just laying here. I know from experience doing these kinds of things that generally speaking the local oscillator will supply a signal as strong or stronger than the noise signals that will be picked up by this loop. So if I discover the local oscillator is really weak compared to the noise signals, I think I can reach a reasonable conclusion that the local oscillator is weak in the radio, or at least go with that idea. So let's put on the SDR radio here. Okay, bring it down into the broadcast band. Here we are. So, I have to check something here. Direct sampling Q branch, good. Play on, maestro. So that's what's on that loop right now. If I put my hand on the loop, a little bit of a variation, not much. If I touch one of these leads, that's just verifying that it's picking up stuff. Yeah, definitely that's the effect of my hand going there. Okay, we got to switch on the radio, and we should anticipate where the local oscillator is. So I believe we left it tuned around 950. Local oscillator would be 1400. 1400 is somewhere around here. So we expect an additional signal to show up here stronger than the rest. That would be the hope. Okay, I'm going to switch on the radio. Is everything ready? It's ready. There we go. Okay, just watch it right around 1400. Something should appear pretty quick. There it is. You can see it on the waterfall display. It's around the same level as the noise signals. That suggests to me it's not bad. Because of where the loop is. If I move the loop more in favor of the radio itself, you get a lot stronger local oscillator there. I'm just holding the loop up near all those coils. So and this is really proving the local oscillator is putting out. Yeah, I don't think we can go with the notion that the local oscillator is weak. Okay, with the radio operating on this band, the antenna signal goes straight to the mixer tube. Then after that, we're talking about the IF. We could check to see what kind of signals are in the IF. That's what's coming out of the speaker. Oh wait, the radio's not tuned. Not tuned the radio. Yeah, that's full blast. That's not a weak signal I'm sending here either. It should be plenty loud, even down with a volume like that. So we know it gets to the grid without any amplification of that mixer tube. Comes off that, goes into the IF at 455. So let's change the signal tracer settings here. So we'll go to band A and we'll tune to 455. It's up in this area here. And no attenuation. Good. So the output of the IF, where's that going to be? Be a little bit at the top of the volume control. Let's take a look. What's that tell you? That tells you the IF is issuing a strong signal. It's just floating around the radio. It's on this cable. I've never done this with this device. So what we're doing is we're approaching the oscillator tube, I think. Wow, is that interesting, eh? No local oscillator appearing up here. At least doing this test. That kind of explains what this plate is all about, eh? One side, other side. Wow. Okay, so we're going to have a listen to pins 4 and 5 on the detector tube. Those are the detector plates. Let me just turn this down a little bit here. Amazing. I'm still amazed at that. 4 and 5 on the detector tube. So the detector tube is this guy here. Plates 4, pins 4 and 5. What we should hear, this is still tuned there. We should hear that, and it should be plenty loud. In fact, let me just turn this down a little bit, because if it's that loud like that, 4 and 5, pin 4 and 5. There's pin 1, 2, 3, 4, and 5. Okay. 4. I don't hear a thing. 5. There's like nothing there. I turn it up. Maybe it's relatively weak at this point. Well, it's way weak in there. Yet it's getting to the grid of this tube, the signal grid, which I think I can get this to easily. Can I rotate all this with it operating? Okay. Not very strong. Let's go right back to here. Oh, wait a minute. So this isn't the IF though. And this isn't the IF. So what's reaching here is the regular radio signal. Not the IF. The IF is afterwards. So did I lose my brain here? I think I did. So we've looked at the two plates. We found no signal. Now we got to look at the input to the IF, which is the output of the mixer tube. Output of the mixer tube. Mixer tube is a 6K8. 6K8. JK. HIJ 6K8. There it is. We want to look at the output of the mixer tube when it's sending on into the IF. Wait a minute. Yeah, mixer tube. Right, local oscillator. Right. So that is very hard to see on here. They've got these little tiny lines. It would be pin 3. Plate of the HX, of the hexode. 3. Pin 3 should be, we should hear, pin 3 is the plate, so pin 3, oh my gosh. It's debatable. So what we should hear though, we should hear the IF there, because it's been mixed. Pin 3. Pin 3. Calling on the IF on pin 3. 1, 2, 3. On this blue wire here. Lots there. So that's what's reaching the tube. That's a signal from that signal generator reaching that tube through a bunch of stuff. So we've got it on the plate coming out. So from there it goes through the IF. When it comes out of the IF, it reaches the plates of the detector, and we couldn't detect it there. It's a failure in the IF string, maybe the IF amplifier tube. So halfway through is the IF amplifier tube. Let's check that out. I'm just gonna jump on the schematic here. So it's a somewhat distorted diagram here. Here's the first IF, here's the second IF. This is the tube in between, isn't it? Yes, output here, coming to grid, plate going through there. V3. V3 is a 6SK7. Okay, 6SK7. By the way, I really didn't intend this picture to come up, but I didn't intend this picture to be anything. When I set up my YouTube channel, I only had one photograph of myself on the computer, and that was it, and I used it. So that's not a thoughtful looking photograph, but not thoughtfully selected at all. Next, back to where we were. So we want to look at the 6SK7 midway tube. Just because I do not want to make mistakes. The 6SK7 is tube number what? So they don't actually name the tubes on this page. They just call them V1 and the like, and they name them here. So 6SK7 IF amplifier V3. I'm just making absolutely sure I don't get it wrong. V3 is right between the IF cans. Okay, so right between the IF cans means it's oh, it's totally hidden from view. It's up in here. That's why I'm having trouble spotting it. It's up in there. 6SK7. Grid and plate. So grid is 4, plate is 8. Grid is 4, plate is 8. Grid is 4, plate is 8. So grid is 4. Count on my hands and knees here. 1, 2, 3, 4. Oh baby. It's not a lot louder than just having it in the air. But it's there. And then plate is 8. So plate without touching the volume. Oh yeah, look. So when I touch the probe, the radio detunes, and that's why the signal is disappearing a bit. But just getting it close. So there's a whopper coming out of that tube, no doubt about it. And from there, it goes into the second IF transformer, and when it comes out, it goes on those plates that I checked that don't show it. Let's check that again. Let's just check that again. 6K8, 6K8, HIJK, 7, 8. That's up here. So we're curious about what is on this grid, which is we're curious what is on. Wait a minute. 6K8 is the wrong tube. That's the wrong tube, isn't it? I've been doing this too long. Too many things running around inside my head. Maybe not enough things running around inside my head. 6K8. 6SQ7. Duh. 6SQ7. So I'm just working in a shop here. If I make mistakes because I'm tired or overloaded, whatever, who cares? If you're a doctor working long hours in a hospital trying to save people who are near death, and you're all worn out and tired out, and you just made a mistake, cost somebody their lives, I really feel sorry for all the doctors and the situation they're in, because they're all overloaded. Something horrible. Okay, down here on this one, it's 4 and 5 that are the diode plates. 4 and 5. And when we look at the schematic here, that's 4 and 5. Now one of these is providing the audio and the other one is providing the AVC voltage. That's how they've done this radio. So this is the one we would be interested in. But both of them should have the same kind of signal on it. This guy's actually picking it off before the transformer, which is kind of interesting how they've done it. And there's just nothing here. It's just a wire. So we found the signal here, loud and clear. We didn't find it here. There's only one thing in between. That's this. Huh. So that's why I really want to check this out, because I don't like what I'm finding. So we will once again try this plate. Don't know which one it is. One of the two. 4 and 5. 4 and 5. 4 and 5. 6 and 2. No, 4 and 5. 4 and 5. On that tube. 4. Counting. 1, 2, 3. This is 4. And this is 5. Son of a gun. There's just like nothing coming out of the second IF. Okay, so the IF transformer is just kind of out of view of this camera because it's just a little too high. It's up under here. So this is, I'm just going to poke at the wires. I'm not really sure what's up. Hey, this radio just started working when I did that. What you're listening to is coming out of the radio. It's working. Let me lower the camera here. Get a look at what I did. This goes into that category of touch something and for some reason it makes a big change. There we are. So you see the blue wire. This is a stick I'm using now. Blue wire here. So that's the wire that goes up to the plate on this tube, the diode, and I checked it. No signal. Then I came down here and all I did, I'm going to do it again, I just touched this blue wire. Wow. What do you want to think of that? The last thing I want to do is make it stop working permanently. You know what? You can read a million books on how to fix radios. No one's going to tell you about this. There's so many things. Well, are we back in the driver's seat now? Well, let's try picking up some stations here. Take this off. This is our antenna. I got a better antenna. A better antenna down here. Let's hook this guy up. This Stay on the broadcast band. Kind of killed it there, didn't it? Let's leave it off for a moment till we get something. If we're gonna. Lots of heterodyne in there. Anybody, somebody? Are we definitely on the, yeah, definitely on the broadcast band. I pretty much did it in. I'm not sure what goes on there. This is a way stronger way into the radio. This is going through those first coils. That's kind of weird. Lots of heterodyne. But it's really messed up. I don't know what to say other than that. This is one messed up radio. Let's try a wire on here. It's really looking for a loop antenna. I have a loop antenna. Why don't we give it what it wants? It's a bit of a random deal here. Just hook it up with clip leads. There's something closer to what the radio is expecting. Whoa, what was that all about? Okay, Mr. Radio. Oh, I got it on full volume here. That's not good. How did it get to full volume? Did it go weak again? Oh, the radio's gone weak again, I think. Yeah. Right in the middle of me doing this. Okay, that's a really bad signs here. These are really bad signs. There are signs of a defective IF transformer. That's what they are. So far, I don't want to settle on that. That's the kind of thing you want to just keep testing till it goes away. So what are we trying to do here now? We're trying to, once again, what happened to the signal? What happened to the signal? Now put the signal generator back on. Did it just come back to life? Why does it like the signal generator so much? It doesn't like my antenna? Does I have the antenna ground? Going down here. Right. It was up here I was fooling around. There I am on the broadcast band. Definitely. It's pretty crummy. This is the signal generator. What the hell? I don't know what I'm doing anymore. I get that from the signal generator. Okay. Okay. So I guess I just been... Now, that's what's available. There's a ton available on here, as there should be. And there's nothing coming through from up here. sure I'm on the broadcast band. Let's go to the first band. Okay, turn this up a bit, get rid of that rumble. I'm gonna put the outdoor antenna where it's supposed to go. This might be a little loud. We'll see. That's with the ground on. What's all this scraping noise? The chassis is super sensitive. The chassis is the antenna. Yeah, I'm definitely losing it here, for sure. Sounds like a radio. And we go to the higher bands. Highest band, 21, 17, 15. We should find something here. Okay, we'll go down another band. This will be like 11, I think. What's happened to your radio? Whew. Sounds like it's receiving, noise. Wow. This is AM radio broadcast. That sounds great, like it's picking up all kinds of noise anyway, that's for sure. 6, 7, 9. This will be 9 megahertz here, band. There should be one strong station.
It was believed that an could God away from helping you with the God's hidden name. Demonic power was in the spoken name. In the ancient world, knowledge of a person's name was believed to give one.
Oop, turn it off. Don't do that. Oh. What happened? Why'd it go so quiet? It's in the mode. It's in the mode. It's in the mode. Mechanical's not doing much. Okay, let's repeat what I did that caused it to come back. Let's sticking this on. That's coming out of my signal tracer. I'm sure it was that one that I touched. Not coming back this time. Now wait a minute. If I could hear it there, why couldn't I hear it up here?
Is the name. Satan hates
The radio
the
came back.
omnipotent power of the self-existent one.
Well, there you've seen it.
Be present everywhere at once and know what each person is thinking.
Therefore, we will stop, because now it's time to think very hard. Twice I have tapped a wire, once down here, once up here. Both times the radio came back to life. I've turned the radio off and on and it went away. These are all indications of a failed connection, in my mind, a failed connection, and a little bit of sparking here, and we're talking about, micromillimeter, tiny little atomic distances or something like that. A tiny little impulse is enough to make and break this, to sort of fuse it and open it, And what is that? What exactly is that? We don't know. Could be something to do with that tube. Could be something going on inside the coil. I don't want to hear that. So I'm going to stop here. It's a really unfortunate situation that's developed with this radio, but it is what it is. It kind of is what it is. Now, just before I go, why don't we see what's going on? Oh, we can't. Yeah, I turn that off. Okay, I was going to flip to the other camera, but it's off. Okay, that's it. Tomorrow, I'm going to spend the day thinking about this, and tomorrow I'll have to do something more to try to prove out or repair the problem. Oh, too bad. See ya.